Hi dear students, now I am going to talk about haloform reaction. Haloform reaction. Haloform reaction is given by methyl ketones. Methyl ketones will give haloform reaction generally. Methyl ketones. The ketones, one side of the carbonyl carbon, they have CH3 group. These are called as methyl ketones. CH3 C double bond O R. Among the aldehydes, only acetaldehyde will give this reaction. CH3 C double bond OH will give this reaction. Among the primary alcohols, only ethanol will give this reaction. Ethanol CH3 CH2OH. Ethyl alcohol only will give this reaction, right? Because in the reaction mixture itself, it is oxidized into acetaldehyde CH3CHO. Okay, and among the secondary alcohols, the alcohols which has the CH3 group to one side of the carbon on which OH group is present. The other side, whatever the alkyl group it is present, one side of the carbon on which OH group is present, it should contain a methyl group, right? These kind of secondary alcohols also gives the haloform reaction, right? Methyl ketones will give this reaction. Among the aldehydes, only acetaldehyde will give, and primary alcohols, ethyl alcohol will give, because in the reaction mixture itself it is oxidized into acetaldehyde, and secondary alcohol CH3 CHOH R type alcohols will give haloform reaction. Let us discuss about what is haloform reaction. Students, methyl ketones when treated with X2/NaOH, the alkali may be, that is NaOH we can take, or Na2CO3 or CaOH twice. Here the X may be chlorine, X may be bromine, or X may be iodine, right? Methyl ketones when treated with X2/NaOH gives haloform and sodium salt of carboxylic acid. Sodium salt of carboxylic acid. When we use a chlorine, then we will get a product as chloroform. It is generalized as haloform. So what is the reactant we are taking is halogen, that is in the alkaline medium, right? So halogen may be chlorine, bromine, iodine. If it is chlorine, chloroform. If it is bromine, bromoform. If it is iodine, we will get a iodoform, right? The famous reaction among this is iodoform reaction, right? So let us take one example for this. CH3 C double bond O, this side if it has a C2H5. So methyl ketone when treated with I2 in presence of NaOH gives Iodoform CHI3 plus C2H5 COO Na will get, right? Iodoform plus sodium salt of carboxylic acid will get. This part, methyl part is converted into iodoform and remaining part is converted into carboxylic acid and base is present, so we will get a sodium salt of carboxylic acid, right? So let us see the mechanism of this reaction. Mechanism is, generally when I2 is treated with the NaOH, I2 NaOH is present in the reaction mixture, it will undergo disproportionation to give NaI plus NaOI. Disproportionation reaction it will give us. Due to hydrolysis, it will convert into HOI. Then HOI will generate OH minus plus I plus it will generate. Instead of iodine, if we use a chlorine, we will get a Cl plus. Bromine is used, then we will get a Br plus. So let us continue this mechanism. Students, a methyl ketone CH3 C double bond O R. We know the nature of the C double bond O is electron withdrawing nature. The electron withdrawing nature of the carbonyl group will make this alpha carbon, alpha hydrogen as acidic. This CH3 I am writing for our convenience as CH2H. CH2H. So in the reaction mixture, OH minus is present because we are doing the reaction in the alkaline medium. So OH minus will take this hydrogen as H plus. Obstruction of this hydrogen by OH minus will generate carbene ion. The bonded pair of electron will lie with the carbon, then carbon will get a negative charge. Then it will form a carbene ion CH2 minus C double bond O R we are getting. So in the reaction mixture there is a I plus is generated. So this will attack on the I plus, then it will make a bond with the I plus. So here that CH2 minus C double bond O R acts as a nucleophile. Then we will get a product as CHI C double bond O R. So for our convenience I am writing this one of hydrogen at the down, right? Again the base is present, so it will remove other hydrogen also. Then bonded pair of electrons will shift on to carbon. Then carbon will get a negative charge CHI minus C double bond O R we are getting, right? Then again this will take one more I plus. It will make a bond with the I plus. Then this is converted to Ci2. One of the hydrogen which is present I am writing it down. Ci2H C double bond O R. Again base will remove the other hydrogen which is remain, right, as a H plus. Then this carbon will get a negative charge Ci2 minus C double bond O R we are getting. One more time this will take that I plus, the carbene ion which is formed will take the I plus. This will convert into Ci3 C double bond O R. We are hitting strongly. So due to hydrolysis, so H is added here. By breaking this bond, OH is added here. Then we will get a CHI3 which is iodoform. Generally this is yellow precipitate, yellow PPD is formed, plus here we will get it as carboxylic acid RC double bond O OH. RC double bond O OH we are getting, but there is a base is present in the reaction mixture. Instead of getting the carboxylic acid, we will get the salt, sodium salt of carboxylic acid we will get, right? This is a mechanism of Haloform reaction. Let us see what are the compounds, what type of compounds will give Haloform reaction. Students, let us see some examples which can give haloform reaction or iodoform reaction. CH3, C double bond O, C6H5. CH3, C double bond O, C6H5. So this is a methyl group is present one side of the carbonyl group. So it will give haloform reaction. CH3, C double bond O, CH3, yes, it will give haloform reaction. CH3 group is present, right? So alcohol, if it is CH3, CHOH, C2H5. This is a secondary alcohol. One side of the carbon on which OH group is present, this has a methyl. So in the reaction mixture itself, it will be oxidized into methyl ketone CH3, C double bond O, C2H5. So yes, it will give haloform reaction. If it is C6H5, C double bond O, C6H5 is given. So it does not contain some methyl group to the one side of the any side of the CH3 group. So it won't give haloform reaction. So in the primary alcohols only C2H5OH will give haloform reaction because it is oxidized into acetaldehyde. Among the aldehydes, acetaldehyde will give this reaction. Ketones, only methyl ketones will give. Students, thanks for watching.